Cali, and up till January this year, I actually worked for large multinationals all my career. And I've joined this startup, Arborea, based on what I'm about to talk about today. Okay, so this is Arborea, but I'd like to just start with a question, if I may. So, can it be true that we actually allow a forest area the size of 17 football pitches to be destroyed every hour to make space for fertile land for food? Actually, it's not true. It's every minute. But what if there was a technology which didn't need fertile land at all to make food? A technology that actually converted carbon dioxide into food, that used minimal water, could be produced anywhere in the world, and most importantly, can be scaled up very cost effectively, very cheaply, and very easily. Let's talk about the biosolar leaf. This innovation is a breathing cultivation system. Rather like the lungs in the body, it breathes in carbon dioxide from any waste industrial source, breathes out oxygen, and along the way, you can make any one of 30,000 photosynthetic microalgae like spirulina. At scale, at speed, and large amounts of mass. From these microalgae, you can make things like proteins, fats, colors, anything that you might need. So as a result, you don't need fertile land then to grow food. Barren land anywhere in the world can become effectively cultivatable farmland, as long as you've got carbon dioxide and sunlight. Yes, that's a challenge in some parts of the UK, I know. But as long as you've got carbon dioxide and sunlight, effectively, non-fertile land can be producing food. But why microalgae? Well, actually, 3 billion years ago, microalgae were the first superfood. There was a lot of carbon dioxide in the air. Microalgae arrived and converted that took in that carbon dioxide and emitted oxygen. And that's the oxygen that we breathe today. And they are packed with nutrients. You see all that protein, bioactive vitamins and minerals, essential fats, all present in microalgae, just waiting. In fact, there are all kinds of documented medical benefits showing how if only you could make microalgae at scale in a controlled way, you could solve issues such as obesity, inflammatory disorders, cholesterol reduction. There's a whole host of things in medical literature right now talking about the benefits that could be possible. But we've started simple at Arborea. We've taken one microalgae only, and from it, we've made a multifunctional protein, a natural color, and a bioactive nutrient concentrate. We could make a lot of other things, but we want to go in stages. And as you can see here, one of the key challenges we had is to make sure that we made a product that the mass market would eat. Because no one really, very few people want to eat something that's green and tastes of microalgae. So what we have here is a very neutral tasting protein extracted from microalgae. It's water soluble, it's multifunctional, it can be used in virtually any food product. And if you remember, there's over 65–70% of it present in microalgae. So as long as you're growing that effectively, you've got yourself a wonderful source of protein that can be used in virtually any foodstuff. So we started with plant-based milk. So it tastes delicious. It's made effectively with protein that didn't need any fertile land from just carbon dioxide and sunlight. And it doesn't even curdle in your coffee. And literally, that protein is available anywhere in the world. And that's just the beginning. Because as a source now, not just protein, you seen earlier that you can make bioactive nutrients, vitamins, minerals, but you can also make personal care ingredients, pharmaceutical ingredients, culture feedstock media, all of it from exactly the same process, the same factory, the same process, the same kit can make all of these ingredients just from carbon dioxide and sunlight. So this is the team. It's a multinational team, a team of people from large corporates like myself and from innovative startups, all working together on, but we have one vision. You see, by 2050, the world will need fertile land the size of Africa to feed it. With this technology, you only need land the size of Greater New York to feed the entire world. So we're Arborea, and we turn carbon dioxide into food. Thank you.